Dear learners, welcome back to the course Ecological Economics or Postgraduate Diploma in Sustainability Science. In the previous session, we have looked into that economic thoughts in ecology, the environment-economy linkages, and we have learned about energy balance principles from the lens of ecological economics, and we also discuss about the concept of absolute scarcity and issues of sustainability. In here, in this session, we are going to look into standard model of economic growth, its concept. So we know that the most useful indicator of magnitude of our environmental predicament is population times per capita resource consumption. Now this is the scale of human economic subsystem with respect to that of the global ecosystem on which it depends and of which it is a part of it. So the global ecosystem is the source of all material inputs feeding to the economic subsystem and is a sink for all its waste. The population times per capita resource consumption is the total flow throughput of resource from the ecosystem to the economic subsystem, then back to the ecosystem as waste. You will see here in this figure of the finite global ecosystem related to the economic system. You will see here this figure illustrates what we call is the bygone era, when the economic system that is depicted by a square was small relative to the size of the global ecosystem. So in this you will see the lower diagram depicts a situation much nearer to today's, in which the economic subsystem is very large relative to the global ecosystem. Hence, the empty world becomes a full world as the economic subsystem expands. So the global ecosystem source and the sink function have large but limited capacity to support the ever-growing economic subsystem. The imperative is therefore to maintain the size of global economy to within the capacity of the ecosystem to sustain it. So it took all human history to grow to the $600 billion or so per year scale of the economy of 1900. Today, the world economy grows by this amount every 2 years. Unchecked today's $16 trillion per, that year global economy may be 5 times bigger only one generation or so. So in this session, we're trying to explain the standard model of economic growth and describe the economic perspective of ecological limits. When we talk about the standard model of economic growth, we know that stable consumer prices, full employment, and increasing per capita wealth are economic and political goals in each and every nation across the world. So aggregate economic growth has been the principal means for realizing all these goals. So comprehensive and independent scientific investigation also provide compelling evidence that the growth of the global economy is not sustainable because it consumes many of the environmental services that underpin the production of goods and services. There are also a growing realization that economic growth does not necessarily go hand in hand with growth in the well-being of the people. So standard measures of economic output such as GNP, gross national product, they do not reflect the growing disparity between rich and poor in most nations, or the environmental degradation which diminishes the health of people, communities, ecosystem, and the economy. So underlying the universal prescription for economic growth are theoretical model that describes the process of growth itself only. So all these models and their derivatives reflect the conventional wisdom about the driving force behind the historic growth in living standard, the role of the environment in the economic process, and the ability of substitution technical change to overcome resource scarcity and environment degradation. So all these models they fundamentally misrepresent important relations of those what we're talking about, role of environment, economic process, etc. and therefore contribute to the expectation that type of economic growth we have experienced in last more than half century, which is we tag it as sustainable. There has been much discussion about over the last few decades about the role of resource in economic development and the compatibility of growth with environment and conservation. So as indicated by recent that exchange and you will see that those between mainstream ecological economics in different review of literature about the debate on this ecological economics and classical economy. So the inclusion of environmental concern in standard growth model is an active area of research in environmental economics in fact. So many application of the neoclassical theory of economic growth to environmental problems, they downplay the likelihood that resource depletion and environment degradation can significantly constrain economic growth. However, if you look, there are a number of reasons to question all this conclusion. The basic growth model in the Nobel Prize winning work by Solo, it does not include the resource at all. The Solo as a basic growth model subsequently was extended with non-renewable resources, renewable resources, some waste simulation services. A common interpretation of standard growth theory is that substitution and technical change can effectively decouple economic growth from resources and environmental services. So depleted resources or degraded environmental services are believed to be substitutable by equivalent form of human-made capital, that is either people, machines or factories, etc. So the term sustainability which we are going to use in this session means either continuing growth or non-declining consumption. So technical and institutional conditions determine whether or not that sustainability is possible. When you talk about technical condition, it refers to things such as mix of renewable and non-renewable resources, the initial endowments of capital and natural resources, and the ease of substitution among inputs. When we talk about institutional condition, that includes market structure, the system of property rights, and system of value towards future generation. Right. If we look from the ecological economic point of view, the elasticity of substitution, which is represented as S between that economy scale capital, means factories, machines, etc., inputs from the environment. What are that? Natural resources, waste that assimilation, ecosystem services, which is a critical technical term that indicates by how much one of the inputs must be increased to maintain the same level of production when the use of the other input is reduced. So a large substitution means S implies that the cost of impact due to the rising price of one input, say natural resource, can easily be scaled by switching to a different techniques of production that favors the use of another input, say capital, right? So as neoclassical economists are primarily interested in what institutional arrangement and not what technical arrangement will lead to sustainability, they typically assume a priori that sustainability is technically feasible. That a unitary elasticity of substitution where that A is equal to 1 means substitution equal to 1 referred to as perfect substitutability, means that as the ratio of the two input is changed by a given percentage, holding output constant, the ratio of their marginal product changes by the same percentage, means in the opposite direction. So perfect substitutability does not mean that resource and capital are equivalently useful. In fact, as the resource availability declines, its marginal productivity raises at infinitum. So even so, perfect substitutability is an unrealistic assumption from a biophysical perspective. So some of the economics like Solo, he explicitly disposed of cases where E is for non-renewable resources and capital is greater or less than unity. In the former case means substitution possibility are large and therefore the possibility of non-sustainability is not an issue. And in the case of capital is greater or less than unity, sustainability is not feasible. If an economy uses only non-renewable resources, Of course, where there are renewable resources, sustainability is technically feasible, at least in the absence of population growth. So, substitution that is technically possible will not occur unless society invests in sufficient capital over time to replace depleted natural resources and ecosystem services. So, the question comes, how much investment does that place depend on the institutional setting of the economy? For example, in an economy where sustainability is just technically feasible, means substitution equal to 1 and there are only 2 non-renewable resources, sustainability will not occur. In either a competitive or centrally planned economy, where the decision rule is the maximization of discounted flow of utility of future generation using a constant and positive discount rate. So, consumption per capita will eventually decline to 0 after an initial period of economic growth, because resources and ecosystem services are depleted faster than the capital can be accumulated to replace them. So, sustainability is achieved under certain institutional settings. Okay. So, if the utility of individual is given equal weight without regard to when they happen to live and the aim is to maximize the sum of utilities over time, then growth in consumption can occur indefinitely. So, this is equivalent to maximizing net present value with a 0 discount rate. Therefore, a constant level of consumption over time is also feasible, obviously. An important result in this concept is the Hardwick rule. The Hardwick rule shows that if sustainability is technically feasible, a constant level of consumption can be achieved by reinvesting resource rents in other form of capitals, which in turn can substitute for resources. The few of the authors like Dixie et al. And it extended the rule of multiple capital stock, while Hardwick extended the rule to open economies. So, then how well do economic models reflect the material basis of the economy? Neoclassical economics argue that the class of growth models that include resource can account for mass balance and thermodynamic constraint with the essentiality condition. If S means substitutability is greater than 1, then resources are non-essential. If S is less than or equal to 1, then resources are essential. So, essential in this case means that given positive non-resource inputs, output is only 0 when the resource input is 0 and strictly positive otherwise. So, the Cobb-Douglas production function, which is a frequent form used in growth model, here is the essentiality condition. So, economists argue that this at least account for the fact that some amount of energy material are required to produce goods and services. Nevertheless, when the elasticity of substitution is unity, this essential amount can be infinitesimal if sufficient manufacturing capital is applied. So, economists also note that resources and capital are interdependent in neoclassical models, in that some positive quantity of resources are required to produce capital assets. Thus, the capital stock cannot be increased without depleting the resource stock. So, some economists acknowledge that an assumed value for S of 1 or greater between energy and other input violates the laws of thermodynamics. However, if we look in general, this important constraint and its implication for substitution have not been integrated into the main body of work on sustainability. So, modern growth theory has sought to improve the standard theory by endogenizing the technical sense through more explicit modeling of investment in human capital, like education, healthcare, and a new technology like research and development. So, this is basically in the form of advancing very fast way. Some authors like Romer's, in Romer's model, they are decreasing returns in the acquisition of knowledge, which is surely more physically realistic. But this Romer's model school of thought still assumes that human-made capital is perfectly substitutable for resource and environmental services. So, looking into what we discussed today, then we can summarize this session that environmental economists have paid increasing attention to the environment, extending the standard tools of micro and macroeconomics to problem resource depletion, waste simulation, and in doing so, it has provided insight into some of the cause and the benefit of alternative plans to ameliorate environmental problems. So some of the environment economists have engaged natural scientists and policymakers in constructive debate about what, if anything, should be done about environmental problems. Yet, despite the increasing pressures by the environment economists on accounting for the role of environment in economic production, their treatment of the topic remain incomplete today also. While some of the relevant mechanisms have been incorporated in individual models incorporating all of that important feedbacks have not been developed so far, and some models using applied work continue to ignore resource and environment. This is what are the backdrops of our economic growth. So with this, thank you very much. See you in the next session.